So yes, sir.
Yes, sir. Clear, sir.
So my phone number is and email ID is Monica madam. Our print out the our print out. Email ID L Dishwal FPY at the rate in dot S dot. Is it visible clearly
Yes, sir.
or you have
Yes, sir.
some
Yes,
problem
sir.
in
Clearly
reading it?
visible, sir.
Very good, so nice. Just 1 minute. Many have not joined till now, and I have some rule in my classes that I will be telling now. You please take care of all those. That is very important, in fact. এইট ম্যাডাম আসুন স্যার দেখুন কেন দেখা যাচ্ছে দেখুন আপনাদের এটা গেলে মিডিয়াটা কঠিন হয়েছিল এই যে ফোকাস করছেন কি আমরা দেখুন पूरा बस देखो पूरा क्लियर है सिलेबस की तुम्हारी ट्राई क्लास की नॉर्मली all are clear comfortable with this hello
Sir,
Yes,
right
sir.
now we are
Yes,
comfortable.
sir.
We will
Yes,
tell
sir.
after writing.
Yes, sir.
oh এটা ফার্স্ট ক্লাস নাম্বার B17 ঠিক আছে পুরা মানে প্যান্ডেমিকটা প্রায় রিকভারি উঠে চাইছে ইনপুটটা করব nothing else is convenient class normal class मेरा वो देखी देंगे पूरा ठीक है just 1 minute you all have got the timetable or not tell me clearly
Yes.
Yes,
Yes,
sir.
sir.
Yes.
We
Yes,
have the
sir.
timetable, sir.
so you have the timetable and you have understood also how the classes are allotted
Yes, sir.
Yes, sir.
no confusion regarding timetable
No, sir.
very good
Yeah.
and you know who is your tutor mentor your tutor mentor's mail id number etc
Yes, sir.
Yeah.
Yes, sir.
Yes, sir.
Yes,
so
sir.
nice and Now I will be telling you a few things about our physics class. So I will be your physics teacher for theory as well as lab. The theory subject was like this. Subject name is physics and code is PH1007. Whereas physics lab subject code is subject name is physics lab. You can write this as full and code is PH1097. So you may be experiencing a new kind of thing. Actually, earlier all of the teachers what they do, they normally write in the whiteboard of the laptop. Other teachers when they were teaching you, they were writing everything in the laptop on the laptop screen of the laptop.
Yes, sir.
Yes or no?
Yes, sir.
Now you are experiencing something different. You are experiencing a different system where I will be teaching you just like physically you are only remotely sitting.
Yes, sir.
So tell me whether it is better or not. If you
Yes.
feel better,
Yes, sir. It is better, sir.
Yes,
it
sir,
is
it is
better.
better.
Okay. So because whatever I will be teaching you now, everything I will write there on the whiteboard. So that is the main advantage. Just like as if you are sitting in front of me and I am teaching you. And you can also ask any of your doubts.
Yes, sir.
Now, this physics theory is of, you know, 04 credit. Do you understand what is the meaning of credit?
Yes, sir.
Very good. And physics law has credit. It has, thank you. Black color नहीं है, so blue color. ठीक है, ठीक है, पछले के तरफ लिखो ना black color. Physics law has credit 1.5. Physics law in each week there will be one class of 3 hours duration as per the timetable. Physics theory, you will have 4 different classes, 1 hour duration in 1 week. Adjusted in between Monday to Saturday, Monday to Friday. But we can also have the class on Saturday, so we may have an extra physics theory class in the form of bonus. Okay, you are following? This physics theory. I will teach you. I will upload the course details. Today I have created the Google Classrooms. You might have gone through. I had sent the invitation. You might have already accepted. Have you accepted? Let me see how many
Yes,
of
sir.
you have accepted.
Yes, sir.
Yes.
Yes, sir.
So there is no confusion regarding it. There are 2 classrooms, one for theory and another for lab. If you look at the classroom title, you can see the theory classroom title goes like this: EH1007 Spring 2020. Whereas the lab class title goes like EH1097. Here is the difference. EH1007 is the code for physics theory subject and EH1097 is the code for physics lab. Both of them will be of 100 marks weightage. But the evaluation pattern is little different. Out of this, I'm going to show you a small PPT maybe I'm going to share it. so that you will be able to better understand. In fact, if anyone has any doubt, can ask me.
सर किसी का
I
माइक
think Arya,
नो सर,
सर किसी का माइक ऑन है सर
माइक
वही
ऑन नहीं है, बैकग्राउंड में
मैं
पूरा
मैं माइक होने से वो सोच रहा हूँ कि शायद उसको कुछ पूछना है.
आई एम सॉरी सर, मेरा माइक ऑन था गलती से.
Here in the classroom, the net is little slow. In my house, the net is fast because I am having Geo fiber. Now it is visible to you people.
So you are sharing a screen, sir?
Yeah, I'm sharing.
Okay.
So how I will upload the course detail in Google Classroom today only by tonight. You will download that and keep it with you. You will have one dedicated copy for the physics theory class. That is very important.
Yes, sir.
Whatever I will be writing in the whiteboard, you must write everything date wise, then and there. Physics theory, 100 marks. It has two components. One is 50 marks for internal assessment. In fact, when the classes are going on, you will be evaluated continuously. You know, last year also you have done the same thing. Mid-sem 20 marks. We will conduct assignments, quizzes, and write-ups at the department level. So we will have few number of assignments. We will conduct few quizzes for all the students of Scheme B. And also I will give you some write-ups in group you have to present. These assignments, quizzes, and write-up taken together constitutes 30 marks. All total it is 50 marks. Before I upload this mark, I will show the mark that you are awarded out of 50 internal assessment. There, I will clearly mention how much you have secured from mid-sem, how much you have secured you have got from assignments, quizzes, and write-up. Also, I will tell you the evaluation procedure. So there is no confusion about that. End sem exam is for 50 marks. Once you appear, they will be evaluated. After evaluation, the marks will go to you question wise. If you have some doubt, you can ask to me. Then within 24 hours, if your doubts are clear, the marks will be retrieved by the examination section and sent for result publication. So this is how the evaluation will be made. Mid-sem, 20 marks, assignment, quizzes, and write-ups. There will be number of quizzes, there will be number of assignments, and one write-up at least in the form of presentation by a group of students. All total taken 50 marks. End sem exam 50 marks. Do you have any confusion regarding this? Do you have any confusion regarding this?
No, sir. No, sir.
Okay. I have another small information to you. I will be very strict on attendance. I will update the attendance in SAP portal every week. By the end of the week, you will be able to see your attendance in the SAP portal as well as both lab and theory, as well as you will be able to see the attendance. If your tutor mentor will be also able to see your attendance. And we will request the tutor mentor, in fact, to share your attendances with your parents every week, with you people also. That is another thing you must remember. Theory attendance I can take any time, maybe in the beginning of the class, maybe during the class, maybe at the end of the class, maybe 2, 3 times during the class. And if I am taking 2 times, any one is absent, that time means he is absent in theory. So you have to remain present for the whole period. Simultaneously, if I call a name, immediately he has to respond within seconds. You cannot say, sir, my mic is not working. Then you have to write the message. You have to come to video. You have to keep your, net facility proper. That is one requirement of the class, because you have opted for virtual mode. So we presume that you are having very good net facility and your progress is not going to be affected. That's why you have chosen to be in virtual mode. So that is one thing. Regarding lab, what we people do, we take the attendance within the first half an hour, normally within first 20 to 15 minutes. Then I explain the topic to be done in that day. Then the the technical assistant assisting me in the lab, he will show you the video in which the how to do the experiment is narrated completely in detail. Then by that time, the technical assistant will provide a set of assignments to different students, different assignment, different data sheet. The student has to work out and submit the PDF in the same class only. Same class only. Within that 3-hour duration, we have designed the modules like that so that it can be submitted within that time only. That is very, very important, you remember. But what I have told you is I will update the attendance by the end of the week. What it means? This is because the attendance will be given to the student only when he or she is present in the class during conduct of the class and has submitted the assignment. If someone is present during the class and has not submitted the assignment in the same week and is not evaluated, then it will be presumed that he is absent in the lab class. So this is very important. You must remember. You will be evaluated by the technical assistant for 4 marks. Then for rest 2 marks, I may have some bypass for you, or there may be a small quiz I will conduct, or at the department level it will be conducted, and whatever mark you will get, I will return back to you in the Google Classroom only. So all academic related phenomena will be there in the Google Classroom. I will not only I will write everything detail in the whiteboard that you should write also in your copy, but also supporting materials I will be providing in the Google Classroom. You will download them, go through them. If you find any difficulty with any particular PDF, you should let me know. So is it clear to everybody regarding lab attendance, evaluation process?
Yes, sir.
Yes.
Any confusion you can ask me. Okay? Course details I will upload today. You download it. You can know what we are going to read in physics in this semester, in theory. If I can get the course details of the lab also, that I will share also with you. So I think you have made the relevant notes, whatever you wanted to. Okay. Now we will be starting the class. I know maybe many of you in your 11th and 12th, you had rotational motion, waves, wave optics, EMI and AC. All these were having some kind of taboo line. Some of you might be fearing these subjects. Here we shall start oscillations and waves. Were you comfortable in oscillations in your 11th class? I want a clear message.
Not very much, sir.
Not very much.
So clear.
Not very much means what?
No, sir.
No.
So no.
So what do you want? A small revision on that, or I should start from this syllabus?
Sir, revision.
Yes, sir.
Yes.
Small revision.
Small
Then
revision.
time will be some time will go due for that purpose. And
Yes, sir. We
syllabus
actually
will
need some
start from
revision.
there. So what to do? How to make up the time? If we are going to, I mean, delegate some amount of time for this purpose, clearing your 11th class, 12th class down, then how to make up? I mean, how to cover how to keep ourselves updated in the syllabus. So what we should do? If people suggest,
We can go through syllabus, sir.
so I will start from the syllabus directly.
Revise our syllabus by our own, sir. You can
Huh?
start.
Yes, sir. Syllabus.
Okay. What I am saying is, if you need some extra thing to be discussed from 11th class and 12th class, then we may have to take few extra classes and that you have to cooperate. If you are not ready to cooperate for that, then I cannot go for all those basics. I will presume that you know all these things and I can start directly the syllabus. So what do you want? Regarding attendance
So in the
and
middle of
theory,
syllabus, if we need any help, we will ask for extra class.
yes, Amish.
So in the middle of the syllabus, if we need any help, then we will ask for an extra class.
But thing is that I cannot go back then. I cannot after teaching few classes. You will if you say, sir, we could not understand all this because we have no clear idea about the basic fundamentals. You teach them, then all the classes that I had conducted will be useless.
Sir,
That is the thing.
Yes,
Yes.
we have the basic fundamentals. Only just make us a little revise. Don't teach the whole.
Okay then. Okay then. Let
It's a
us
quick
let us
revision, sir.
let us discuss something. Let us discuss.
sir,
Just quickly.
And
I
tell,
think you can
yes.
just initiate the thing we have to use from 11th and 12th and then complete the topic. Like we will ask you doubts wherever we want. Like we don't understand this thing or we want a little revision over this topic only. That thing. Like not whole
Okay. Then
oscillation is blank for
let us.
us.
Okay, I understood. I understood. Let us devote one to classes for that purpose. Let me check how much you understand from the topic oscillation. Any one of you who can define what is oscillation? What is oscillation?
Sir, two information.
So back and forth motion like in a rhythmic manner.
Rhythmic manner, rhythmic term you normally you people use when you talk about music. You can say oscillation. A body is said to be oscillating when it is to and fro type manner, to and fro type motion, period. A to and fro period. Here I use two phrases. One is to and fro, another is periodic motion. Let me first make it clear what is the periodic motion. Oscillation is to be periodic in nature. Any to and fro motion cannot be oscillation. Like suppose you went to your school, then return back. Then next day you did not go to the school. Next day you went to the school and return back. First day you remained in school for 3 hours. Second day you remained in school for 5 hours. You cannot call it as oscillation. We will say that it is a to and fro kind of motion. So all to and fro motions are not oscillations, nor all periodic motions are oscillations. An oscillation has to be to and fro type as well as periodic type. My question is, what do you understand when you say periodic motion?
Sir, occurring at regular intervals.
Yes, repeating after equal intervals of time. Means motion repeating itself after equal intervals of time. See the variable here. Time, independent variable. Can time be a dependent variable? Can time be a dependent variable?
No, sir.
No. It goes on continuously changing. Time, in fact, goes on continuously increasing. Time always an increasing independent variable. Equal intervals, just like rotation of sun around rotation of earth around sun. So this is sun, this is earth. Now after a regular interval earth is rotating around sun. So this motion is given. But you cannot call it oscillation because it is not to and fro time. It is periodic in a closed loop. But still it is not an oscillation. Oscillation has to be periodic as well as to and fro. Every periodic motion has a time period. It is the time interval after which the motion is getting repeated. Another thing I want to point out, it cannot happen. A periodic motion cannot be like this, that in the first oscillation or periodic motion the time interval is different and in the second periodic motion the time interval is different. No, it cannot happen. Periodic motion means the time interval after which the motion is getting repeated is same for all the time. But to become to and fro time, this is a repetitive motion. All periodic motions are repetitive motions. But to and fro motions means the motions that go from one end to other end and then return back. And then the same kind of motion is getting repeated again and again and again. But these to and fro motions can be categorized into two groups. One is translatory oscillation. Another is rotatory type to and fro motion. Translatory type, like this. Suppose a particle is going back and forth along the space line path repeatedly. So this is linear oscillation. Oscillation is taking place along a straight line path. Or maybe a curvilinear oscillation like this. So this is called like this curvilinear oscillation. These are all translatory type of oscillation, where the central mass of the body follows a path which is either a straight line or a curve. That means the central mass of the body is displacing from one place to another place to follow a path. But suppose there is an oscillation, a to and fro type of motion, where the central mass is not displacing at all from one position to another position. But you can see one kind of oscillation. Like this, if you can see this pen, suppose you are able to see this pen, can you mark this? What I am doing?
So you are rotating that.
But not a complete rotation I am doing.
No, sir, not a complete rotation.
Yeah.
Half rotation.
If I am doing this to and fro type,
Oscillation.
If I
Got
am doing
it.
this periodically, after a fixed time interval, this will be called as a rotatory oscillation.
Yes, sir.
So in case of rotatory oscillation, you have a body. The body goes like this repetitively after a fixed time interval, but the center of mass is not moving.
Sir, your voice is not clear, sir.
Why is it not
Yes, sir.
clear?
Not clear.
Yes, sir.
Yes, sir. Very low voice
Yes.
is coming.
Now,
Sir, it's
echo sir, echo आवाज
Yes,
सर
sir.
वो
Echo.
वो आप दूर हो जा रहे हैं ना सर, माइक से
क्लैरिटी नहीं है सर और आवाज
क्लियरिटी
साफ
नहीं
नहीं
आ
आ
पा
रहा
रही
है।
है सर।
सर जब आप थोड़ा दूर हो जाते हैं तो साउंड पूरा लो हो जाता है सर।
ओके, दूर हो जाने से बताएं साउंड थोड़ा लो हो जाएगा ही क्योंकि मोबाइल से पास दूर चले जा रहे हैं।
सर हेडफोन पहन लीजिए सर।
I will use your earpods actually.
Yes, sir. That's
Mic if possible, but it will take some time. I will take a tripod also. In my house, it is not a problem. I am taking the class from college now because of one meeting I had been to college. So that is why. But it is audible, na?
Yes, sir. It's
Yes.
audible, sir.
Now it
Sir,
is
maybe
clear,
because of
sir.
the empty class, it's echoing a lot.
No, no. If all the students will be active and keeping them on themselves unmuted, then obviously there will be much echo. That is true. Do you understand the meaning of rotatory oscillation?
Yes, sir.
See, when you talk about the linear oscillation, the body physically displaces from one place to another place, resulting in linear displacement or linear distance covered. But when a body shows exhibits rotatory oscillation, you can mark it is rotating like this. Its central mass must not be displacing. It is only covering some angle in one side, then again rotating. For the timing, because you know this linear oscillation is more easy to handle. So for the timing, we shall start with this, but we can extend the idea. Whatever we will have. All kind of mathematics also can be extended to this rotatory kind of oscillation only by replacing some quantity by rotating quantities. For example, suppose you are dealing with linear displacement, there we will deal with rotatory displacement. Here I am dealing with linear acceleration, there I will deal with rotatory acceleration. Here I am dealing with force, there I will deal with torque. The equivalent quantity that you understand from rotational motion in 12th class.
There is
Here,
fixed axis of rotation also.
yeah, it will have an axis of rotation, of course. Every rotation is associated with an axis. That is an obvious thing. So now, would you understand the difference between to and fro motion? I mean, to and fro motion, periodic motion. Could you now understand the meaning of these terms?
Yes, sir.
Yes, sir.
Periodic motion, and when I can say a to and fro motion to be oscillatory type.
Yes, sir.
Yes, sir.
So nice. Every oscillatory motion has a fixed time period. And when one time period is completed, we say one oscillation is complete. So one oscillation means one time period means one oscillation complete. So going from one end to other end, then again returning back. This is one oscillation. Or you can say starting from any point, going to other end, one end, then again returning back to that point, and then again returning, going back, going to other point, distinct point, then again return there. Simply, one oscillation. In case of rotatory oscillation, also the same thing. The time taken for one oscillation is time period, and there is no strict difference between oscillation and vibration. Vibrations are nothing but the oscillations taking place very, very fastly with small amplitude. They are termed melodies. Normally, we never say a simple pendulum is vibrating. We say a simple pendulum is oscillating, but we say the guitar string is oscillating, vibrating. The string of the guitar, when it is flogged, we say it is vibrating. So there is no strict difference between oscillation and vibration. Only fast oscillations with small amplitudes of small particles or different particles as a whole, a collection of particles, aggregation of particles, as a whole is termed to be vibration. Every electric motion is associated with a frequency term. This frequency is defined as number of oscillations in 1 second. So if you have one oscillation in 2 seconds, then the number of oscillations in 1 second is 1 by t. So this is what we call as frequency, and frequency has the unit hertz. In sum, it is Hz. Remember all these things. These two terms are used not only for periodic motions but also for oscillation. Both of them. Please try to understand this. These are very basic things that I am telling you that you have also get in your 11th. Just to refresh. Now, as I told you, it is easier to start with linear oscillation because that is taking place along a straight line graph. So, let me characterize a linear oscillation. That can be used, the understanding can be used to extend to characterize any rotatory oscillation. What are the characteristic parameters of any oscillation? So you may, if you do not understand the meaning of characteristic parameters, I can explain you like this. Say Prius rise. Are you there, Prius?
Yes, sir.
Where are you from? Where are you from?
Sir, I am from UP, but currently I am living in Delhi, sir.
What is your age?
Sir, I am in 18, sir, right now.
18. What is your height?
Yes, sir.
What is your height?
5'10", sir.
5'10" kilometer.
Yes, sir. 5 foot 10 inch.
So never loiter like this. You should tell with unit. These are the quantities who require units for their complete specification of their amounts.
Yes, sir.
And
So
what is your
can
mass?
also-
What is your mass?
Sir, marks in which exam, sir?
Mass, your mass.
Mass,
Mass.
weight.
Mass is same as weight.
No, sir,
No,
sir.
no,
They are
sir. Mass
different.
and weight is different, sir. Mass,
sir.
weight is the
Achha,
by the
yeah, first tell me whose mass is more, 1 kg cotton or 1 kg iron? Whose mass is more?
Sir, both are
Sir, same, sir. Same,
same
sir.
mass. Same mass, sir.
Then why you are confused when I asked what is your mass? I am in physics class. I am not in front of a shopkeeper who will expect that I should ask like this, give me 2 kg weight of potato. But there if I say give me 2 kg mass of potato, he will beat me.
Yes, sir.
Many times in science you understand it properly, whereas the layman do not understand it properly because they when utter something mean something else. Okay, we will be very careful. Yes, now, if I characterize place and want to know how place is different from Sasank Deepak, obviously I will compare their heights, I will compare their mass, I will compare their age, I will compare their color, I will compare their nature, activities, performances. So these are the characterizing parameters by which we can distinguish Sasank Deepak from Prius range. Every physical entity has its characterizing parameters. How it is different? There may be 5 different oscillations going on simultaneously. How I can distinguish one oscillation from the other? So every oscillation has its own characteristics. How to specify and estimate all those characteristics that I am going to tell you. One characterizing parameter for any oscillation is the time period. All calculated frequency. They are the same thing. If you know the time period, you can get the frequency. So you cannot say that time period and frequency are two different characterizing parameters. Either you say time period or frequency. What other characterizing parameter you can say? Any oscillation, what other possible characterizing parameter to specify the oscillation they are distinguishing?
Sir, amplitude.
Yes,
Amplitude.
amplitude, very good, amplitude. And what other?
Sir, length of the size.
Energy of oscillation, no matter. I am going to change your so many ideas. You will see the course of time. First of all, what is time period or what is frequency? I did not have to tell. Let us first analyze an oscillation. A linear oscillation. A particle is moving to and fro along a straight path. Let us visualize this oscillation carefully in the language of a layman, from the eye, in the eye of a layman. A layman would understand, see, a particle comes from this side and returns back from here. So he calls this point as extreme position of oscillation. Similarly, this is also another extreme position of oscillation. So X and Y are extreme positions of oscillation. Every oscillation has experiments, whether it is linear oscillation or rotatory oscillation, it has some experiments. Now, particle is oscillating, so it is coming and returning back from X. So, what should be the velocity at X? Particle has to return back from X. What should be the velocity at X?
Sir, please could you repeat that?
Sir, 0.
What I am asking is, particle has to come and return back from the point X, the experiment. So, what should be the velocity at X?
0.
0.
0, sir.
0.
Must be. Otherwise, by virtue of its inertia of motion, it will overshoot that point. And then we cannot say that this is the right thing. Clear?
Yes, sir.
Now I have a doubt here. If the velocity is 0 here at the experiment, it will remain there at rest. Then how the oscillation will be possible? For oscillation to continue, the particle has to return back to Y. But you have seen that at rest the particle must have the velocity 0. If it is, then particle should sit there idle.
Sir, the
Yes.
kinetic energy becomes 0, but it still has potential energy. So that potential energy will push it through to go to Y.
See. Just check your understanding through this example. Suppose you have kept your book on the table. Now it is at a height from the surface of Earth. So it has some potential energy or not?
Yes, sir.
Then why not it is automatically moving? Why not that potential energy is immediately not getting converted to kinetic energy?
Sir, both it is horizontal, na? So it
नॉर्मल से यस सर
normal से हो जाएगी contradictory.
हाँ यह कॉन्ट्राडिक्ट हो जा रहा है
My question is very simple.
सर
If the body has some energy with it in the form of potential energy being on the table, why not it is utilizing that energy to move forward
सर
or move down?
कोई एक्सटर्नल फोर्स अप्लाई नहीं किया जा रहा है इसीलिए
So what you mean to say is for conversion of energy or to do some work, an external force is involved.
यस सर
No, sir, potential energy से नीचे खींच रही है.
Friction is cancelling out.
Listen. If that is the fact, what you mean to say, then for the particle to go from X to Y, an external force must be needed. If you want your particle to go from X to Y, so that oscillation will continue, then obvious that there must be an external force associated with the oscillating particle. Yes or no?
sir that time the body must be retarding
Whether it is retarding or accelerating, that's a separate thing. Retardation and acceleration will be there only when there is a force involved. My question is very simple. Particle has zero velocity at one end. If it stays there permanently, oscillation is not going to happen. But oscillation to occur, particle has to return back to Y. You are saying that if it wants to return back from Y, X to Y, it needs an external force.
Yes,
So
sir.
this is
There
the
must
thing that
be a
I am
force.
reminding that for oscillation to occur, there must be an external force acting on the particle who is oscillating, and that force must be pushing the particle from x to y. Is it correct?
Yes, sir.
Yes, sir.
Yes, it is. Yes, it is
Yes,
correct.
sir.
So what you understood from here? You understood one thing, that without involvement of an external force, no oscillation is possible. Wherever you see any oscillation in nature, there must be an external. Remember, external force. That means that force must have some external origin. Then go to my. I am having another doubt. Can an isolated system ever oscillate? Can an isolated system ever oscillate?
No, sir.
No. Why?
There will
No
not be
external force to.
force.
Then for external force, there must be another external agent
Yes,
involved through interaction with the oscillating particle.
yes, sir.
तू oscillate करना चाहता है ना सौभाग्य, तो तेरे को मेरे साथ जोड़ के रहना पड़ेगा कोई फोर्स के थ्रू, कोई इंटरेक्शन के थ्रू. तो चुपचाप बैठ के बोल नहीं सकता, किसी के साथ इंटरेक्शन फोर्स के माध्यम पे नहीं करेगा और बोलेगा कि मैं झूमता रहूंगा. ये संभव नहीं है. नो आइसोलेटेड सिस्टम कैन ऑसिलेट. It has to be associated through an interaction with external agents present in the surrounding. Wherever you go to the oscillation of a simple pendulum. There it is the gravitational force of Earth who pulls the pendulum from one end to other end. So that you understand now, you can do it very well. Okay. Now, if there is a force for oscillation to take place to be associated with, then this force will push the body towards y. So obviously the particle will be accelerated because it is moving under the action of the force. You know, when a body moves under the action of a force, it got accelerates. When a body moves against the action of a force, it got decelerated. But here, the force is pushing the body from x to y. Oh, body has no initial velocity. That means body is moving under the action of force. So its velocity must be increasing. Here is another problem. If its velocity goes on increasing, by the time it reaches to y, it will have a very high velocity. So obviously, like its inertia, it will overshoot. If it will overshoot, then y is not an extreme point. Because y being an extreme point, the particle has to return. Are you all following me? Are you all following me what I mean to say?
Sir, you are
Yes,
not
sir.
Sir,
Sir,
audible.
you're
when
audible.
you are
Sir,
going
you are not audible.
forward, you are
Inaudible,
becoming
sir.
inaudible, sir.
The audio is very unclear.
What I mean to say is, if there is a force, then only oscillation will be possible because particle will be pushed from x to y. Its velocity will increase. Now, if the force will go on acting on the particle and pushing it from x to y, by the time it will reach at y, it will have a high velocity. So it will overshoot y. Then how can y be an extreme position? Because y is an extreme position, the particle has to return back from y. Yes or no?
Sir, there should be a stopping force at y.
Stopping force. Can force stop a body instantly or it takes some time interval?
It takes some
It takes
time.
some time.
Take some time.
Then why you are saying there should be a stopping force instantly? It should act for a time interval. If there is a stopping force, okay, I understood. There is a stopping force. In that case, the stopping force should stop the body there. Then the body will be at rest and it will oscillate. But you want the oscillation to continue forever. So what can be the possible situation here? Oscillation is possible provided this force will be acting on it and pushing it from X to Y, but there should be a point in between O, after which this force must be opposite the motion. That means the force must be reversing its direction. Then what will happen? After pushing this force, the velocity will decrease because the body is moving against the force, and by the time it reaches to Y, its velocity will be zero. But still the force should be present. The force should not act for some time interval only. It should always be acting on the particle. Then this force again will push the body and increase its velocity till it reaches to. After that, force immediately reverses. This is normally what happens when a body is in stable equilibrium. You know what is stable equilibrium? In stable equilibrium, whenever the body is displaced from equilibrium, a restoring force acts on the body, which returns back the body to its original configuration, original position. Then only the body can be in stable equilibrium. Yes or no?
Yes, sir.
Yes.
Yes, sir.
So, what you understood then? Very simple. Oscillation only can take place about a stable equilibrium position. If a body is in unstable equilibrium, if a body is in neutral equilibrium, you cannot result oscillation of the body. Because only in the case it is in stable equilibrium, a restoring force can be associated. Now you tell me, did you have these ideas earlier? आपके पास ये समझ पहले से था क्या?
Yes, sir.
हाँ,
Yes, sir.
तब तो इसको नहीं पढ़ाने से भी चलता.
सर रिवीजन के लिए मतलब
रिवीजन कराएंगे. सर छोड़ेंगे नहीं आपको, आपको बोलना पड़ेगा. नहीं, अच्छा चलो बोल लेते हैं. So what we understood till now? We discussed what is oscillation, we discussed its extreme ends, we discussed that there must be a restoring force associated with the particle during oscillation. We discussed that oscillation can only take place about a stable equilibrium position, and we also understood that in any oscillation there are experiments as well as there is a point O, which is the equilibrium position, and after which the force reverses its direction. Which force? Restoring force. So, for any oscillation to take place, there must be a restoring force. Along with the restoring force, there may be other forces. Along with the restoring force, there may be other forces. But restoring force presence is essential. Without restoring force, no oscillation can take place. Now, here comes the amplitude. We have already defined amplitude and frequency. Here comes the amplitude. The distance of the experiment from the equilibrium position, this is called the amplitude. And the distance of right from the equilibrium position, that is another amplitude. It is not necessary that both the amplitudes be equal. But there are so many oscillations where both the amplitudes are equal. If amplitudes are equal, then it is a symmetric oscillation, or many times called as isotropic oscillation. A symmetric oscillation. But if in an oscillation the left amplitude and right amplitude are not equal, then the oscillation is said to be anisotropic. So could you understand the difference between isotropic oscillator and anybody who is oscillating is an oscillator? Anywhere there is an oscillation, we can say there is an oscillator. Both these statements are not same. I will elaborate later and explain you how these are not same. But could you understand the difference between isotropic oscillation and anisotropic oscillation?
Yes, sir.
Okay.
Yes, sir.
So you understood now what is meant by amplitude. Every oscillation has amplitude. Maybe a common amplitude if the left amplitude and right amplitude are equal. May not have a common amplitude if left amplitude and right amplitudes are not equal. Then the oscillation is said to be anisotropic. Normally, in any solid you pick up, the atoms or molecules you will find to be oscillating anisotropically, not isotropically. Their left amplitude when the molecules come closer, the amplitude, and when they separate, the amplitude, they are different. So they are all anisotropic oscillators. The molecules in a solid, they are all anisotropic oscillators. You have read about this in 11th class in dynastic, the mechanical properties of solid chapter. You might not have properly identified that, but that has been written in the NCERT. I will tell you about
Sir, in isotropic, the both amplitude are not equal, but in anisotropic, both are equal.
No, I told the reverse. I told that in isotropic oscillation, both the amplitudes are equal. It is a symmetric oscillation. Isotropic means symmetric oscillation. In anisotropic oscillation, both the amplitudes are not. Clear?
Sir, could you repeat the point once?
What I told is, if the oscillation is taking place such that the oscillation is symmetric about the equilibrium position, where the left amplitude and right amplitude are equal, then the oscillation is said to be isotropic one. But the oscillation, it is taking place in such a way that the oscillation is not symmetric about the mean position, which results the left amplitude and right amplitude to be different from each other. We say it is an anisotropic oscillation. Clear?
सर ये यहाँ पे सर ओ मीन पोजीशन है ना.
ये O को ही इक्विलिब्रियम पोजीशन बोलते हैं और इसी को ही मीन पोजीशन बोलते हैं.
ओके.
Every oscillation has an equilibrium condition, and that equilibrium condition, when is considered for a particle in oscillation, because मैं आपका आइडिया को बदलने जा रहा हूं. आज मैं बोल रहा हूं कि पार्टिकल ऑसिलेट कर रहा है, आगे आगे तुम देखोगे मैं बोलूंगा क्वांटिटी ऑसिलेट कर रहा है, एंटिटी नहीं क्वांटिटी. तो मैं एक छोटा सा सवाल आपको छोड़ के जा रहा हूं आज. एंटिटी और पार्टिकल के बीच में, एंटिटी और क्वांटिटी के बीच में क्या डिफरेंस होता है, नेक्स्ट क्लास में आप बताना एग्जांपल के साथ. व्हाट इज एन एंटिटी, व्हाट इज ए क्वांटिटी, हाउ दे आर डिफरेंट, what we understand by physical entity, what we understand by physical quantity, with examples. This is a task to you people, and you will tell me in the next class. Here I have a small information to you. What we observe is, for any oscillation to take place, there must be a restoring force. Without a restoring force, no oscillation can take place. Along with the restoring force, there may be other forces present. But restoring force is a must. And one interesting thing, in all oscillations that you see in nature, in all oscillations that you see in nature, whoever force is playing the role of restoring force must be a conservative force. I think you understand the difference between conservative and non-conservative forces. Do you know the difference between conservative forces and non-conservative forces?
Yes sir.
A conservative force is one work done by which does not depend on the path followed, work done by which over a closed path is always zero. A non-conservative force is one work done by which always depends on the path followed. What I mean to say here is the interesting thing, that in any oscillation, the force who is playing the role of restoring force must be a conservative force. You see, gravitational force, electric force, spring force, they are conservative. Whereas friction force, viscous force, air resistance, they are non-conservative. Electromagnetic damping, they are non-conservative. Can you show me an example of oscillation where you can show that a viscous force or an air resistance is playing the role of restoring force? Never. In all the examples of oscillation, you will find that either it is the spring force, or it is the gravitational force, or it is the electrical force who is playing the role of restoring force. There may be other forces present, I am not denying that. But whoever is playing the role of restoring force must be a conservative force in all oscillations of nature. And perhaps you people know that whenever a body moves under the action of conservative force, only its total energy remains conserved. This is another statement that you have read in work energy power chapter. In work energy power chapter 11 class NCRT, if you refer to, they are clearly about conservative forces written, as well as the concept of potential energy, and after that, under what condition the energy of a system is conserved. That has been written. I am talking about energy of a system. System plus surrounding makes the universe. System plus surrounding makes the universe, and energy of the universe is always conserved
Sir,
in whatever situation.
sir, sir,
Yes.
sorry to say, sir, but we have a BE class right now, sir.
Okay, I am going to conclude this.
Yes, sir.
So please go through this in detail and remain present. Come to the class in time. I will start taking the attendance from Monday onwards, and I will keep a record of it. Once the SAP portal is activated, I will immediately upload after the. Otherwise, I will also share the information with your tutor mentors, and whatever discussion I made today, please go through it in detail, and you can ask your doubts in the next class. I will have a small interaction for 5 minutes, then I will take progress.
Thank you, sir.
Okay,
Yes, sir.
bye.
Thank you, sir.
Bye bye.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you. Thank you, sir.